Welcome to the Deep Dive, where we take your sources and extract the most important nuggets of knowledge. Today, we're diving into the really essential world of quality assurance in software development, our mission for this deep dive, to give you a clear, concise, and engaging understanding of the core concepts, processes, and terminology in QA. Think of it as, well, a shortcut to becoming truly well-informed about how software quality is ensured, from the basics right up to advanced stuff.
And our source material today is particularly insightful, I think. It's a comprehensive guide to QA interview questions and answers, which is great because it offers this fantastic practical lens into what truly matters in the field. Whether you're just starting out or you're experienced, it helps us understand not just what things are, but crucially, why they're important in a real-world context.
Okay, let's unpack this then. If someone's new to this space, maybe just trying to get a handle on it, what's the very first distinction we need to make? I mean, what's the real difference between QA, quality assurance, and software testing? People seem to use them interchangeably.
Yeah, they often do. And it's fascinating because while they're definitely related, they are distinct. Quality assurance, or QA, is fundamentally about the process. It's monitoring how you produce the software, making sure the methodologies, the steps, everything leads to quality.
Okay, so the how.
Exactly. Software testing, on the other hand, that's about the functionality of the final product. Does it meet the user's requirements? So one is about how you build it, making sure the kitchen's clean, the recipe's followed, like you said.
Right, the recipe analogy.
And testing is checking if the cake actually tastes good. It's really a key activity within the broader QA scope.
That makes so much sense. Okay, QA is the big picture framework. Testing is a critical piece inside it. So once the software is built, there's another distinction that sometimes trips people up. Build versus release. What's the difference there?
Right, good question. A build is essentially a numbered version of the software that the development team gives to the testing team. It's purely for internal use, for testers to evaluate, find bugs. It's an intermediate step.
Internal check. Okay.
A release, conversely, is also a numbered version, but this is the one formally handed over to the customer, the end user. So the implication is huge. A build is for internal checks, iteration. A release is for customer value, stability.
Got it. Internal working copy versus the finished product for the world. Makes perfect sense. And what about this term testware? It sounds a bit technical. What does it actually cover?
Testware, yeah. It basically refers to all the test artifacts you need to actually design and run a test. So things like your test cases, your test data, your test plans. It's essentially the toolkit and the documentation for testing.
The toolkit. So it's not just the tools, but the plans and data, too.
Exactly. It's the whole package you need to perform testing effectively and repeatably. Without good testware, things get messy fast.
Right, consistency. Okay, so talking quality inevitably leads to talking about bugs or defects. Our source brings up two terms that sound similar but mean very different things. Bug leakage and bug release. What's the critical difference?
Yeah, this is a really important distinction. Bug release happens when software is handed over, maybe to the testing team or sometimes even to early customers, knowing a specific defect is there. Usually this is because the bug's priority and severity are low. It's understood it can be fixed later. It's a calculated risk.
Okay, so it's known, planned for almost.
Right. But bug leakage? Well, that's a problem. That's when a bug is discovered by the end users or the customers themselves. It means the testing team failed to find it during their process. One is controlled, the other is an oversight, a failure in testing.
Oof. That leakage definitely sounds like something you want to avoid at all costs. Impacts trust, reputation.
Absolutely.
So when a bug is found internally, hopefully, what happens next? It's not just fix it, right? There's a process. Can you walk us through the bug cycle?
Certainly. It's a pretty standard workflow, usually. First, the tester finds it, logs it, and assigns it to the development manager, typically with an open status, like, hey, found this.
Okay, step one, open.
Then, the team looks at it. If it's a valid defect, they'll plan to fix it. If not, maybe it's a misunderstanding or intended behavior, it gets marked as rejected.
Rejected, okay.
Now, sometimes a bug is real, but maybe not critical for this specific release. If it's out of scope for now, it gets postponed.
Postponed. Makes sense.
If the tester realizes this bug was already reported by someone else, they'll mark it as duplicate. Avoids double work.
Duplicate. Good one.
When a developer actually starts working on the fix, the status becomes in progress.
In progress, active work.
Once a developer thinks they've fixed it, they change the status to fixed.
Fixed. but not done yet.
Not quite. The tester then needs to verify the fix. They rerun the test case. If it passes and doesn't cause new problems, then it gets a closed status, journey complete.
Wow, okay. Open, rejected, postponed, duplicate, in progress, fixed, closed. That's quite the journey, but it ensures tracking. So beyond bugs, what exactly is a test case? Is it just a simple checklist?
It's more structured than just a checklist. A test case is a specific condition you want to check against the application. It includes really detailed info, the exact steps to follow, any prerequisites the environment needed, and crucially, the expected output. What should happen?
Ah, the expected result is key, so you know if it passed or failed definitively.
Precisely. It makes testing repeatable and objective.
And switching gears slightly to automation, we hear data-driven testing a lot. Sounds efficient. What is it really?
Data-driven testing is an automation framework. The core idea is testing the same functionality with many different input values. But the key part is that these input values aren't hard-coded in the script. They're read from external files like CSVs, Excel sheets, databases.
So you separate the test logic from the test data?
Exactly. And that's why it's so useful. You can run the same test script against hundreds, even thousands of data variations without changing the script itself. Think about testing logins with tons of different usernames and passwords, or checking product calculations with varied inputs. It massively boosts coverage and efficiency.
Ah, I see. So you write the test once, then feed it lots of different data. Very powerful. Okay, we've got bugs, test cases, data-driven approaches. How do teams actually plan all this work? Let's zoom out. What's a test strategy?
The test strategy is the high-level document. It's the big picture. It covers things like the overall approach, the scope, the resources needed, the schedule for testing activities, what tools you'll use, priorities, and the general types of testing you need to do for the project. It's the master plan.
The blueprint. Okay. And how does a test plan fit in, and then the test cases?
Right, so if the strategy is the blueprint for the whole building, the test plan is the detailed plan for, say, laying the foundation or building one specific floor. It outlines the specifics for a particular testing effort or phase, objectives, scope for that phase, time frame, environment details, entrance exit criteria, risks, much more concrete.
More focused.
Exactly. And the test cases, as we said, are the individual granular steps within that plan. They're the actual instructions for hammering the nails or checking the plumbing based on the test plan.
Strategy plan tests. Got it. A clear hierarchy. Now, you mentioned types of testing in the strategy. There seem to be so many. Can you give us a sense of the variety?
Oh yeah, there's quite a range, each looking at quality from a different angle. You've got unit testing developers testing tiny pieces of their own code, integration testing, checking if those pieces work together, regression testing, super important, making sure new changes didn't break old stuff.
Always a risk.
Definitely.
Yeah.
Then shakeout testing, maybe a quick check on a new build. Smoke testing, like a basic health check. Functional testing, does the feature do what it's supposed to? Performance testing, how fast is it? White box testing, where you see the code, black box where you don't.
User perspective.
Right. Alpha testing internally, beta testing with external users, load testing, stress testing, system testing. The list goes on. Each serves a purpose.
Wow, quite the toolkit. Let's maybe zoom in on just a couple of those. Branch testing and boundary testing. They sound quite specific.
They are, and they target common problem areas. Branch testing is about code paths, making sure every possible decision point, every if statement branch, gets executed at least once during testing.
Covering all the code's potential routes.
Pretty much. And boundary testing focuses specifically on the limits, the edges. If a field takes numbers 1 to 100, you test 1, 100, but also 0, 101, maybe an empty value, because bugs often lurk right at those boundaries, off by one errors, things like that.
Ah, testing the edges. Smart. And what about testing under pressure? You mentioned load, stress, and also volume testing. They sound similar. How do they differ?
Good question. They are related but distinct in their goals. Load testing simulates expected heavy usage. Think Black Friday traffic on an e-commerce site. Can it handle the expected peak load?
Expected peak. Okay.
Stress testing pushes it beyond the expected limits. What happens when you overload it? Where does it break? How does it recover? It's about finding the breaking point.
Finding the limits.
Right. And volume testing is specifically about handling large amounts of data. Can a database handle millions of records efficiently? Can it generate massive reports without crashing? It's focused on data capacity and processing.
Load is expected users, stress is breaking point, volume is data quantity. Got it. Now, what's fascinating is how testing has adapted, especially with things like Agile development. What's different about Agile testing?
Agile testing really flips the traditional model. In older methods, like waterfall, testing was often a separate phase after all development was done. In Agile, coding and testing happen simultaneously, in short cycles or sprints.
Yeah.
Testers are part of the development team.
Embedded in the team.
Exactly. It requires constant communication, rapid feedback. You test features as they're built. The big benefit is catching bugs much earlier, when they're cheaper and easier to fix. It's a much more collaborative approach to quality.
Shift left, finding issues earlier. Makes total sense. Let's touch on a few more practices that maybe indicate deeper QA experience. What's configuration management? Sounds important for control.
Oh, it's critical. Configuration management, or CM, is the process for controlling and documenting all the components of a project and any changes made to them over time. Think source code, documents, test scripts, server setups, everything. It includes version control, change control, release management. Basically, it ensures you know exactly what version of everything you have, the changes are tracked, and you can reliably rebuild any version of the software. Prevents chaos.
Essential for managing complexity. Okay, what about ad hoc testing? Sounds random.
It can seem random, but it's actually a valuable technique. Ad hoc testing is where a tester explores the system kind of freely, trying to break it without following predefined test cases. It often involves negative testing, trying invalid inputs, unexpected sequences of actions. It really relies on the tester's intuition and experience.
So structured randomness based on experience.
You could put it that way. It's often done after formal testing and can uncover bugs missed by the structured approach, like a final sanity check by a skilled human.
Okay, makes sense. And when bugs are found, especially lots of them, how do teams decide what to fix first? What's bug triage?
Bug triage is like sorting patients in an emergency room. It's a process to manage and prioritize incoming bug reports efficiently. The steps usually involve checking if the report is complete, analyzing the bug's validity, assigning it to the right person or team to fix, and critically, assigning a severity, how bad is the impact, and a priority, how urgently does it need fixing. It ensures the most critical bugs get attention first, based on business impact.
Prioritizing the chaos. Very important. Now, for scaling testing, automation is key. We talked about data-driven testing, but what's the overall strategy for an automation test plan? Is it just record and playback?
Definitely not just record and playback, though that might be a starting point. A good automation test plan is strategic. It involves planning what to automate and what not to, preparing the environment, maybe recording an initial scenario, but then enhancing the script with things like error handling, adding checkpoints to actually verify results, using loops for data, then debugging, running, and clear reporting. The goal is reliable, maintainable automation that gives fast feedback.
Much more involved than just hitting record.
Okay. And how does a quality audit fit into all this? Is it just more testing? No, a quality audit is different. It's a systematic, often independent examination of the quality processes themselves. Its purpose isn't to find bugs in the software, but to assess if the established quality control procedures are actually being followed, if they're effective, if they meet standards. It's like auditing the QA process itself, not the product directly.
Auditing the auditors, in a way, or auditing the process they follow.
Exactly. Auditing the process to ensure it's working as intended.
Okay. Thinking bigger picture now. Beyond finding individual bugs, what are some common solutions QA thinking brings to broader software development problems?
Our source highlights several key ones that really impact the whole life cycle. One is insisting on clear, complete, agreed-upon requirements before coding starts. So much trouble starts with unclear requirements.
Get it right up front.
Yeah. 2, creating realistic schedules with enough time for all phases, including testing and fixing, not just coding time. 3, starting testing early and often, alongside development that shift-left idea again. 4, using prototypes during design so customers can see and react early. And 5, using good communication tools so the whole team stays connected. A lot of these prevent problems rather than just finding them later.
Proactive quality building, not just reactive bug finding. Good point. Let's quickly touch on 2 more specific testing types. CRUD testing and thread testing. What are they about?
Sure. CRUD stands for Create, Read, Update, Delete. CRUD testing focuses on verifying these basic data operations, usually against a database. And you create a user, read their details, update them, delete them. Fundamental stuff.
Basic data operations. Got it. And thread testing.
Thread testing is an integration testing approach. Instead of integrating module by module, you integrate components needed to fulfill a specific end-to-end user transaction or thread. So you test a whole user journey early, like logging in, adding an item to a cart, and checking out, even if some underlying details aren't fully built yet. It verifies major flows.
Testing the whole journey. Okay. Now, what about test-driven development, or TDD? This sounds backwards, writing tests before the code. Why do that?
It does sound backwards at first, but it's a very powerful development practice. The basic rule is, write a failing automated test case first, then write just enough production code to make that test pass, and then refactor the code. The tests actually drive the design of the code. It forces you to think about requirements and testability upfront.
So the test defines what the code needs to do.
Precisely. It leads to very modular, testable code, gives you an instant regression suite, and often results in fewer bugs overall. It's a discipline, but very effective.
Fascinating. Changes how you think about coding. Finally, documentation. Always important, especially in complex fields like SQA. What are some key documents we'd find?
Oh, documentation is vital for communication and traceability in Square A. Key types include the requirement documents themselves, obviously,
Yeah.
test plans and test cases we've discussed, test metrics reports tracking defect trends, test coverage, etc., test logs records of what was run, when, and the outcome, test incident reports, detailed bug reports, test summary reports, high-level status for stakeholders. You might also see things like user profiles, task flow charts. These documents ensure everyone's on the same page and quality efforts are visible and trackable.
Wow. Okay. That is a comprehensive look. We've really taken a deep dive today into this incredibly nuanced and vital world of quality assurance. From those basic but crucial distinctions like QA versus testing, build versus release, right through the bug cycle, all those testing types, and the documentation holding it together.
Yeah, it really highlights that ensuring software quality isn't just about finding bugs, right? It's a whole systematic process. It involves planning, strategy, careful execution, using the right techniques, and improving continuously. Understanding this is so valuable for anyone involved with software.
So what does this all mean for you listening in? Well, next time you download an app, update your software, or even just use a website, maybe take a second to think about all those layers of QA, all the planning, the different tests, the bug tracking that hopefully went into making it work smoothly for you. How might knowing this change how you look at software issues or even think about tech careers? Maybe next time something glitches, you'll have a better idea of where that bug leakage might have happened. Definitely something to mull over.
CTS is the